Hello friends, today we are going to see how to reach the end of the array with minimum number of jumps. So let's see. This is the array and you can start at index 0 and you have to reach up to index 9. You can take jumps in this array from place to place and you can reach 9. Now what can be the length of the jump? So it is written here, see. The maximum jump length from an index will be equal to the number at that index, means the element at that index. Means see here, from index 0 you can take a jump of at most 2 places because the element at index 0 is 2. So you can take a jump of at most 2 places. So at most 2 places means the jump can be of 1 place or 2 place. Okay. Means from index 0 you can go to index 1 or you can go to index 2. But you cannot go to index 3 because this is the maximum limit of the jump from index 0. Only up to index 2 because the element at index 0 is 2. So the length of the jump is at most 2 places. Okay. So the maximum length of the jump is equal to the number at that index. Okay. This is the meaning. Let's take one more example. Suppose you are at 4th index. Now from this 4th index, you can take a jump of at most 3 places. See, at most 3 places means you can reach up to 7. So, as you can take the jump of at most 3 places, means you can take a jump which is of length 1, 2 or 3. Okay, means from index 4 you can reach to 5th index or to 6th index, or a length of jump 3 can take to the 7th place. But you cannot go to the 8th place because the length of the jump is at most 3 places. Okay. Now in this way you have to start at the 0th index and have to reach at the 9th index with the minimum number of jumps. Okay. So this is the problem statement. Now let's see what are these two arrays. Okay. So this minimum jumps array is the array in which the minimum jumps required to reach each place is written at that index. Means suppose at the 4th index I write x jumps. Okay. Means you can reach at 4 from 0 with x jumps, and x is the minimum number of jumps. Okay. So that is going to be written in this array. And what is the jump path array? This jump path array holds the value of the location from where we jump. Okay, the last stop of jump. Means suppose from 0 you go to 3rd index, then you go to 6th index, and then you go to 8th index. Just assume this. Okay. So at the 3rd index 0 will come. That means at the 3rd index the jump was taken from 0th index. Okay. Then at the 6th index the jump was taken from the 3rd index. So we will write 3 here. Then at the 8th index the jump was taken from the 6th index. So we will write 6 here. So that is this array. Means from where we are jumping, those locations are going to be written here. Now let's start to solve this problem. So we use two variables I and j to trace this array. Variable I visits each position in the array, and for each position we find out the minimum number of jumps needed to reach that position. Okay. and for every I, here for every I, j starts from 0. So you can see here is the sample for loop, nested for loop, just for making you understand how this works. So see, I starts from 1 to n and j every time starts from 0 and it goes up to I. So let's see how do we do this. So see, I starts from 1 and now we will calculate the number of jumps needed to reach at I, means 1. Now you will ask me, what about 0? So for 0, as it is the starting position, only 0 jumps are needed to reach at 0 because we are starting from there. So there is no jump needed. Okay. So 0 jumps are needed and this value is hard coded, right? So I directly starts from 1. Now for every I, j starts from 0. So I will start from 0. Now see, at the jth index, what is the value? 2 is the value. Means the maximum length of the jump from 0 can be of length 2, means 2 places. So obviously I is in range of j, means from index 0 we can reach index I, means the index 1. So with one jump we can reach from j to I. So one jump is needed to reach at index 1 from the starting of the array. Starting is the 0th index. Okay. And see, so we write it here 1 as the minimum jumps needed to reach index 1, and in the jump path array we write from where we jump. So from where we jump? From 0. We jump from 0 to 1, okay, to reach at index 1. Now, as the computation for index 1 is over, let's go ahead, means let's increment I and j again starts from 0. You will perfectly understand as we go further, okay. So now see, as the value at j is 2, whether I is in range of j? Yes, it is in range because you can have a jump of 2 places from j, right? You can have a jump of at most 2 places. So you can reach I. So with one jump you can reach I. Means for second index you can reach with one jump. Okay. And from where we jump? From the 0th index. So I write 0 here. Now let's check another possibility by incrementing j. So let's increment j. So j comes here. Now from j, whether I is in range? Yes, it is in range because the element or the value here is 1 and I is 1 place away, right? So I is in range. Means with one jump I can reach I, right? So how many jumps are needed to reach at second index? So the total number of jumps will be first to reach at jth index and then to ith index, right? Because from j to I you can reach in one jump, but there are some number of jumps required to reach at j. Because see, you have to start from 0, then you go to first index and then you go to second index. In this case, means you go via first index, right? So from 0 to j, how many jumps are needed? See, here it is written from 0 to j means the first index, one jump is needed. Okay, this one jump plus from j to I, so 1 plus 1. So if you go via 1, if you go via the first index, this first index, then you need 2 jumps, right? Yes, so you need 2 jumps to reach at I. So here already there is an option of one jump, Means if you directly jump from 0, to the second index, you can go with only one jump. But if you go via the first index, if you go via the first position, then you need 2 jumps. So obviously the minimum out of 2 and 1 is 1. So we keep 1 and we prefer jumping directly from 0. We prefer directly jumping from 0 index. So we keep 0 here as it is because we jump from 0. So in this way you have to select the minimum value of jumps. Okay. We can go via many places, but you have to select the place from where the number of jumps are minimum. Okay. So as we go further, you will be very clear. Okay. Now as j has reached I, so I is now incremented and j again starts from 0. Okay. Now check whether I is in range of j. No, it is not in range because from j the maximum length of the jump is 2 places, but I is in the 3rd place. So you cannot reach from j to I. So you increment j now. Now check whether it is in range. No, it is not in range. I is not in range of j. So you increment j. Okay. So check whether I is in range of j. Yes, because the value is 3. So you can reach j. So one jump from j to I. And how many jumps to reach at j from the starting index? 0. From 0 to j, how many jumps are needed? See, 1 jump is needed. Plus this 1 jump from j to I. So 1 plus 1, 2 jumps are needed. Okay. So 2 jumps to reach at 3rd index, right? From the starting index via j, means the second index. So from 0, first we jumped to 2nd index and then we jumped to 3rd index. So we went via 2. So from where we jumped? From 2. Okay, from 2 we jumped to the 3rd index. So as j has reached I now, let's increment I. And j will again start from 0. Okay, now let's see. Again I is not in range of j. So increment j. Now see, I is not in range of j. So increment j. Now here, yes, I is in range of j. So you can jump. So this 1 jump plus to reach at j from starting index, means from 0th index, to reach at j, how many jumps are needed? 1 jump is needed. So this 1 jump. So 1 plus 1 is 2. Okay. So 2 jumps are needed. And from where we jump? See here, from where we jump to index 4? From the 2nd index. So I write it here in the jump path array. Now let's increment j to check other possibilities. So I increment j. Okay. Now check whether I is in range of j. Yes, it is in range. So we can jump from j to I, and to reach at j from the starting position, how many jumps are needed? It is written here, 2 jumps are needed. So 2 and plus this 1 jump. Okay. So 2 plus 1 is 3 jumps. If we go via index 3, see, if we go via index 3, then 3 jumps are needed, right? But already to reach to the 4th index, we have a path which takes only 2 jumps, and that path goes via the 2nd index, from 0 to 2 to 4. This takes only 2 jumps. So we find out minimum from 3 and 2. So minimum is 2. So we keep 2 as it is, and we prefer going via 2nd index. Okay. And now as j has reached I, we increment I, and j again starts from 0. right? So again I is not in range of j now because j is 2. So j is incremented. Again I is not in range. So j is incremented. Now I is in range of j, right? So one jump from j to I, and to reach at j, one jump is needed. So 1 plus 1 is 2. So write 2 here in this empty box, and from where we jump? From the second index. Now let's increment j to check other possibilities. So we increment j and we come at index 3. Now from j to I, yes, I is in range of j. So we can jump, and to reach at j, how many jumps are needed? 2 jumps. So 2 plus this 1 jump. So 3 jumps. Okay. So 3 jumps are needed if you go via node 3. Okay. So what is minimum out of 3 and 2? 2 is minimum. So we prefer going via second index. Right? Now let's increment j. So see, yes, I is in range of j. We can make one jump. But to reach at j, how many jumps are needed? 2 jumps. So 2 plus 1 is 3. So see, already we have an option of 2 jumps, and 2 is minimum. Out of 2 and 3, 2 is minimum. So we keep 2 as it is. Okay. And now as j has reached I, we increment I. And j again starts from 0. Okay. J again starts from 0. Now see, I is not in range of j. So j is incremented. I is not in range of j. J is incremented. I is not in range of j. So j is incremented. Now again I is not in range of j. So j is incremented. Now here, yes, I is in range of j. Okay. So we can make one jump, and to reach at j, how many jumps are needed? 2 jumps. So 2 plus 1, so 3 jumps. As the box is empty, directly write 3 jumps there, and from where we come? From the 4th index. Okay. Now let's increment j to check other possibilities. Now see whether I is in range of j. Yes, it is. So we can make a jump, and to reach at j, how many jumps are needed? It is written here 2. So 2 plus 1. 2 plus 1. So 2 plus 1 is 3. So 3 jumps are needed to reach at 6th index. And as already we have an option of 3 jumps. So as 3 is equal to 3, so we don't need to change this value. Okay, we keep 3 as it is, and we prefer coming from the 4th index. Here you can choose any one. See, via 4th index also 3 jumps, and via 5th index also 3 jumps. So you can prefer anything. If you want to prefer the 5th index, then you can write 5 here. If you want to prefer 4th index, you can write 4 here. You can take any one. Now, as j has reached I, let's increment I. So I is incremented, and j again starts from 0. Okay. So again I is not in range of j. So increment j. And again I is not in range of j. So increment j. See here, not in range. Not in range. Then yes, it is in range. 3 places from j is I. So it is in range. So to jump to j, how many jumps? 2 jumps are needed, and from j to I, 1 jump. So 2 plus 1 is 3. 3 jumps. And from where we jump? From the 4th index. Okay. Now let's increment j. So j is incremented. See, from j to I, yes, they are in range. So to reach to jth place, how many jumps are needed? 2 jumps plus this 1 jump. So 2 plus 1 is 3. 3 is equal to 3. so we keep 3 as it is, okay, and we increment j. So see, yes, it is in range. So to reach to jth place, 3 jumps are needed and this 1 jump, okay. So 3 plus 1 is 4, and as 4 is greater than 3, we keep 3 as it is, okay. So now as j has reached I, let's increment I. So I is incremented and j again starts from 0. Now again not in range, then increment j. Again I is not in range of j. So in this way you can go up to here, the 5th index. Now at the 5th index, I is in range of j, okay. So to reach at j, how many jumps are needed? 2 jumps plus this 1 jump up to I, okay. So 2 plus 1 is 3. So 3 jumps, and from where we jump? From the 5th index we jump, okay. Now increment j to check other possibilities. So yes, it is in range. So I is in range of j. So to reach at j, how many jumps are needed? 3 plus this 1 jump. So 3 plus 1 is 4, but 4 is greater than 3. So we keep 3 as it is and we increment j. Now yes, the value here is 1 and we can reach to the 8th index with 1 place. So we can have 1 jump, and to reach to j, how many jumps? 3 jumps. So 3 plus 1 is 4. 4 is greater than 3, so we keep 3 as it is. Now as j has reached I, let's increment I, and j will again start from 0. Now again we can come up to the 5th index. Till that index I is not in range, and at the 5th index I is in range. So to reach up to j, 2 jumps plus we can have 1 jump. So 2 plus 1 is 3. So 3 jumps. So from where we reach the 9th index? From the 5th index. So I write 5 here, and now I increment j. So see, yes, it is in range. So reach at jth index, 3 jumps are needed, and from j to I, 1 jump. So 3 plus 1 is 4, but 4 is greater than 3. So we keep 3 as it is and we increment j. Now check, it is not in range because the value is 1. So I is not in range of j. So we increment j. Yes, it is in range. So to reach at jth place, 3 jumps plus this 1 jump. 3 plus 1 is 4, but 4 is greater than 3. So we don't consider that value. We just keep 3 as it is. Now as j has reached I, you have to increment I, and when I is incremented, I goes greater than n. So the loop ends here, okay. So in this way you can see the answer in the last box. So from 0 to the last index, 3 jumps are needed. This is your answer. 3 jumps are needed. And what is the path? So you can get the path from this array. See, at the 9th index, from where we jumped? From the 5th index, okay. So we jumped from 5th index to the 9th index, okay. And to the 5th index, from where we jumped? From the 2nd index. So from 2nd index we came here. And for the 2nd index, from where we jumped? From the 0th index. And this is the starting, okay. So see, the path is 0, 2, 5 and 9. So in this way we find out the minimum number of jumps to reach end, and this is the path, okay. See, here is the code. So you can see, if I is less than j plus array of j. J plus array of j means what? For example, you are here, okay. Suppose j is here, just an example, and I is pointing to the 4th index. So j plus array of j means 2 is j plus array of j is the value. So 2 plus 3 is 5. So if I is less than 5, if I is less than or equal to 5, means as I is 4 here, 4 is less than or equal to 5, that means I is in range of j. That is what we are checking here, whether I is in range of j. We are checking that by adding the value at j. Okay, and if it is in range, then we go inside, and as you know, in the minimum jump array, we fill the value which is minimum of the original value there and value of the jump from j plus 1. Okay, minimum number of jumps to reach j plus 1. Now you will ask me, when the box was empty here, then how to find out the minimum? So I will tell you, at first while starting the program, you have to initialize all the values as infinity. You have to initialize all the values as infinity. Then this minimum function will work. So minimum of infinity and whatever is the value will be the value. Okay. So you have to initialize this array as infinity. And then you have to hard code the value at 0th index as 0. Because this is the starting index. So this is how this program works. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.